Welcome everyone. I believe this is our 88th live stream geometry. We have 4 other people here with us right now, and I am going to do some problems from the geometry discussions and problems Discord server. So the same place we've been taking them for a while. Many of you probably know the Iranian Geometry Olympiad happened in the past couple of weeks. The problems are still confidential, so I'm not going to work on them just now. I'm going to wait till they're released before we start working on them. All right, so with that, I will share my screen. So if you'd like to join us in future sessions, feel free to email me at mgreen801@gmail.com. It's in the description of my video, and we meet every Sunday at 8 a.m. US Central Time. All right, so this problem looked a little easier, so I decided we could start with this. So we have triangle ABC. So I chose 2 riddles and a couple middle riddles. We have altitudes BF and CE intersect at the orthocenter. So that's H. All right. So H is the orthocenter. So this is EF. And this is H. And then I can delete these. M is the midpoint of BC. And N is the midpoint of EF. So basically triangles ABC and AEF are similar, and M and N correspond. And we also have MN as perpendicular to EF. So that gives us a good amount of information. And then MH, so let me hide this. MH intersects AC and AB at R and S. So I might have to extend a couple sides. Oh, whoops, didn't mean to draw that. So here's MH. And we know MH passes through the antipode of A. So it might be worth drawing that. Yeah, let me make this a line instead of a segment. So yeah, that's a well-known fact. MH passes through the antipode of A, and we want to see where it intersects AC and AB. So something like that. So AC at R, AB at S, and then we take the projections of R and S onto AB and AC. Okay, so it looks like I'll have to draw both lines. So R onto AB and S onto AC. And should be T. And this point, look a little nicer. This point should be Y. All right. And we want to show Y, T, and N are collinear. I wonder if they're collinear with H also. Looks like it might be. Let me hide a couple things. All right. Oops. Thanks for joining, Ryan. So we have a good number of people here with us. All right. And now I will draw everything back in. That's y. And I think that's everything, right? I think I've drawn everything I need. We could label this point 2. So you know that this is cyclic right here. I'll draw that in. This angle, because they're all 90-degree angles, angle AGH is 90, because it's well known that V is the antipode of A. So and we know that MN is perpendicular to EF. We know this is a cyclic quadrilateral, so maybe it's worth drawing that. This is 90 and that's 90. Just move this down a line. There we go. So this looks like it. We want to show angle TYR plus equals angle EYN. I wonder if these, let's check if these always pass through the orthocenter. Yeah, it looks like it does. So we could try to show YN and H are collinear, and then we could try to show TY and H are collinear, and that would solve it. It's pretty interesting. So yeah, if we could show YN and H are collinear, then by symmetry, we could also prove that TN and H are collinear. Okay. And basically we know angle EH, well, this angle EHN is equal to angle CHM from the similar triangles. So we want to show CHM is equal to EHY. All right, looks like we have another person joining. Hey, Mai, thanks for joining us. So this is our first problem. Just a heads up, yeah, I was gonna say you're on video. So this, hello. This is our first problem. It's supposed to be medium difficulty, so not extra hard. Thanks for joining. So yeah, angle ENH is equal to angle CHM. And we want to show that's EHY. We also know that this is cyclic, so we have a lot of cyclic quadrilaterals here. Any other cyclic quadrilaterals we can find? So SY is parallel to BE. So angle EHY is equal to angle SYB. I'm not sure how helpful that is, but I'm sorry, it's SYH. So we want to show angle SYH is angle CHM. I wonder if SYH is similar to CHM. Let's see. It doesn't really look like it. Well, maybe. Let me check it. I always get the angle the wrong way. It's counterclockwise. So no, those are not similar. But we should have this angle equal to this angle. Oh, I did it the wrong way again. I think this should be the same thing. Yes. We have to prove that. Just a moment.
Maybe we can show that angle RYHE equals S.
Say that one more time.
SHF, YHE and SHF, because we have SHF is equal to NHE, since NHM is the median.
Oh, I think that solves the problem. So you said we know that angle SHF is NHE because this is a semedian. Okay. Okay, let me think about that. Hold on just one sec. Someone messaged me on Discord. All right, so Leia just joined us. Thanks for joining, Leia. Okay, so we wanted to show angle ENY. If we can show angle ENY equals ENH, that's that would solve the problem. And we know ENH is FHG. Sorry, EHN is FHG, which is CHD.
I think I've solved the problem.
Okay.
By a spiral similarity. So, as you've already seen, GAYS and RTYS is cyclic.
Yeah.
Yeah, also RTAG is cyclic. That is also obvious by 90-degree angles.
Oh, yeah. Okay.
And so, when you have we can just look at GAYS for now.
Okay.
We basically can have that there is a spiral similarity taking SY to BC, and like because of that is true for any circle which passes through A and G and like intersects AB and AC like that. And we basically have that S and Y are corresponding points in similar triangles BHF and CHE.
BHF and CHE.
Exactly.
Okay.
And by that we have that angle FHS is EHY.
Okay.
Yeah, and similarly FHR is EHT. So we have that HY and T are collinear. So right now I just saw that we need to show also that analyzing this. I mean, it is not complete, but at least we have that HY and T are collinear.
Okay. All right. But the thing is, if we show H, N, and Y are collinear, then by symmetry that would solve the problem because it would mean that H, N, and T are collinear.
Yeah.
It's still interesting. It's still an interesting idea.
Oh, okay. This is actually also easy, as HS is the C-median and HN is median.
Okay. Yeah. So basically, so in triangles VHF and CHE, you said S and Y are corresponding, right?
Yeah.
Okay. So I think so I'm trying to think, that's because so the spiral similarity that takes VHF to CHE is centered at is it centered at G? Wait.
Alternatively, without spiral similarities, we can do power ratio.
Okay.
Maybe that is a bit easier to state just when you write the solution.
Okay. So basically the ratio of the power of B with respect to these two circles is the same as the ratio of the power of C with respect to those two circles. And from there, we get that EF over FS is CE over EY. Is that kind of what you're thinking? Yeah, because, okay, GSY is similar to GFE is similar to GBC. So kind of from there, we could get those ratios, right? Okay, I'm gonna write what Nguyen just said. S to Y. So basically by a spiral similarity at G, we have GSY is similar to GFE is similar to GBC. And from there, or I could say GSF is similar to GYE and GSB is similar to GYC. So I'll just write it like that. I don't have to use. So GSF is similar to GYE. And GSB is similar to GYC. And then combining the two, we have SF over FB is YE over EC. YE over EC. Okay, so basically that means in triangles HFB and HEC, that S and Y are corresponding. So angle SHF is equal to angle YHE. Okay, so in triangles, so HFB is similar to HEC. All right. Sorry, I know it's covering up the diagram. And S corresponds to Y in that similarity. And so once we know that, then we know angle SHF is equal to angle YHE. And then we also know angle SHF is angle NHE because so basically that solves the problem because triangle FHE is similar to triangle BHC, and that means that angle SHF equals angle CHM, which is equal to angle EHN, or I'll say NHE. And so these two imply that, so angle YHE is equal to angle, all right, I like this. So that means that YN and H are collinear, and similarly TN and H are collinear. And that means that Y, T, and N are collinear. Y, T, and N linear. All right. So I did leave out one step, so I'm going to write it here, but it's well known that HM passes through the antipode. So actually, I don't know if I need any of these circles, really. What did I use here?
For the spiral similarity, we did use the circles.
Oh yeah, we need the circles for the spiral similarity. So
Actually, we can delete T and R because they are unnecessary and too big circle too.
yeah. So I'm going to leave them just because they're part of the problem, but it's kind of basically we're making a similar argument here. So yeah, you're right that like we didn't really need them when trying to solve the problem. So it's well known that HM passes through the antipode of A. Let HM intersect ABC at G. And then I'll just say by right angles, AGSY, AFHE. So AGSY, AFHE. And are those only two we need? Oh yeah, for now, those are the only two. So those are cyclic. All right, I think we are good for now. All right, so anyone have any last questions on this before I move on? All right, so I'm going to move to the next one. So this is a middle riddle. I did have some, okay, this one is a full riddle. So this one's going to be a little harder. We have a triangle ABC, and then we have the midpoints of AC and AB. N and P. All right. CP and BN intersect the circle at R and Q. So those are the two medians. And whoops, did not mean to do that. And then we see where RQ intersects the sides. All right. So I'm gonna rename these points. So R and Q are those 2 points. R, and this is Q, and S and T are those 2 points. Should be T and S. Then we see, where do the circles T and B and ABC intersect at V, and SPC and ABC intersect at W. So this is V, and this is W, maybe right there. And AV, we want to show AV equals AW. This looks a little tricky. And it's a full riddle instead of just a middle riddle, so it's going to be harder. All right, let's see what we can do here. So let me try to make the diagram look a little nicer. Yeah, see, triangle or SPC is such a narrow triangle. I wonder, what if I make ABC like a taller triangle? I think the picture might look a little better. Yeah, I like that better. Okay. What if, yeah. I think that looks good. All right, so obviously this is going to be the centroid right here. We know PN is parallel to BC. Call this G. PN is going to be parallel to BC. So basically we want to show arc AW is arc AV. And that's the same as showing angle VBA is angle WCA. I don't think BV and CW are parallel, but maybe they are. Let's see. It almost looks like it. I think they are just slightly, yeah, they're not parallel, although it's very close. One sec, I'll be right back. All right, thanks for waiting. We want to show these two angles are equal. Or we could try to show ACV and ABW are equal. Doesn't have to be this point necessarily. So I'm going to delete these. Like we could also show that ARV and AWQ are equal. I think so, or I think we can. Oh, actually, no, that's not equivalent. Oh yeah, it is. So yeah, ARV and AWQ. Could those be similar? Let's see. Oops. I don't think they are. No. Let's see. Yeah, how would we show that? Bill, I wonder if there's some point on this arc and we could show that the angle between that and V is the same as the angle between that and W, so we could show like an angle bisector. Maybe the midpoint of arc BC. Or what if I did this and then we want to show ADV is ADW. Yeah, somehow we want to get like an angle oh, no, I think that's a coincidence. Yeah. Let's see. Is there any kind of special point? Like, what if I do this and this? No. I want to find some special point on this arc where I could show that this is an angle bisector. So not point D, but some other point. But if I try this and this, there we go. That looks like it might be it. And I wonder if that's the, no, I just got lucky. That doesn't actually always lie on that arc. But yeah, I could just try the midpoint of arc BC for now. And then we would want to show, we'd want to show that this is an angle bisector. but I'm not sure if that's so easy. I'm going to erase that just for now. Let me try this. So A should lie on this. This point would be the antipode of A. Yeah, so I could always just draw in the antipode of A. I just don't know if it would be that helpful. What if I drew these 2 points in? So I want to show angle VBD is WCE. And VBD is VTD, which is VND. So I want to show angle VTB is WSE. These almost look like altitudes. I would be very, no, they're not altitudes. I highly doubt it. Yeah. I wonder if these concur. This, no. I was thinking this, but. So if we draw this point, it's the same as saying that FD and FE are isogonal with respect to VFW. Let's see. what if we redefine the problem? What if we let W prime be the point where AV is equal to AW prime? And then we try to show that, I'm going to delete D and E. I feel like they might be confusing. What if we let W prime be where AV is equal to AW prime, and then we try to show that cyclic? So we want to show SWC. If we did that, we want to show SWC as SPR, which is half the sum of those two arcs. Okay, so basically, I think we want to show WS bisects arc AB. Let's see if that's true. Yeah. If we could show WS bisects, what just happened there? I thought I had it. Is that right? No, I don't think that's right. Oh no, I think what we want to show, that we draw WS and we let it intersect the circle at point, I think we want to show DB is equal to AR. Let me check if that's true. Yes.
That is quite nice then, because we want to show that CD is a C median then.
We want to show that CP is CD is a semedian. Oh yeah, good point. Okay, so.
Could you repeat again why this is equivalent?
So actually, I kind of worked backwards. I said let W prime be the point so that AV is equal to AW prime. And then I want to show that this is cyclic, W prime SPC. So I want to show that angle SW prime C is equal to angle SPR. And if you work out the angles, that's the same as showing that arc AR is equal to arc DB. And so, yeah, that would be the same as showing that this is a semedian.
Oh, okay.
You don't think WS bisect? No, WS doesn't bisect the arc AB, but arc DB is equal to arc AR. That we want to show. So D, basically D and R, DR is like parallel to AB, and arc DB is equal to arc AR. So maybe, yeah, maybe it would be better, yeah, to draw the semedians
Wait, so you're redefining W, and then you want to prove that arc dB equals arc RA?
Yeah, exactly. Which is the same as showing that CD is a symmedian, from what Stefan just said. So yeah, we want to show ADBC is harmonic. And can we project through point S? So ADBC, if we project through S, A and B get swapped, D goes to W prime, and C would go to some other point. So then we could try to show that's harmonic. So AEBW we want to show as harmonic. AEBW prime. Let's check that that's true, but it looks like it's true. Let's see. Yes. Okay. Yeah, I don't know if introducing point E makes it easier or harder. So yeah, we know EP is a median. If we could show EW prime is a symmedian, then that would solve it. And what happens if we do this? I don't even know what F is. What is F? This is a median. We want to show that. We want to show EW prime as a symmedian. So we know ACW prime is ACV if we assume it this way. So let's see. So this is a median EP in triangle AEB. And we want to show EW prime is a symmedian, but angle AEW prime, that intersects arc AW prime. So that's going to be the same as arc AV. So we want to show arc AV. So if we draw this point, then we want to show arc AV is equal to arc BF. I'm just getting confused, but I think I'm getting somewhere. Maybe this is the midpoint of arc B. Maybe F is the midpoint of arc BC. No, not quite. But okay, so getting a little confused. But we want to show. Sorry. We want to show that EP and EW prime are isogonal, which is the same as saying arc AV is equal to arc BF. So we really just want to show AF is parallel to BV. That's kind of interesting. Yes. We want to show AF is parallel to BV. So I could probably clear a bunch of stuff off the figure. Yeah, we don't even need, so we don't need W prime anymore. So I can hide a bunch of stuff. I think oops. I think we just need to, we need to show AF is parallel to BB. Hide that. What was D? I forgot how I defined all these points. I can hide that. In fact, do I even need? I think I need everything else here. So CS meets the circle at E, EP meets it at F, and I want to show that AF is parallel to BV. And I think I can get rid of this. So I want to show that this angle equals this angle. So I add the foot of the sea altitude. Yes. This point right here. So yeah, I don't know if we really even need point F. We want to show that angle SEP. Yeah, I don't know if I made the problem easier or harder by doing this, or if I should go back to the way it looked before.
I think I have proved the C-median thing, but I really need to check this. It looks a bit suspicious.
Okay.
Okay. So define W as in the problem, the intersection of CPS and ABC.
Okay.
And we will basically just do some angle chasing and it will do it. So that's why I think it is quite strange. So, okay. We want to show that angle AWD is equal to, basically it is equal to ACD, and that should be equal to PCB because of this immediate thing.
Well, if you define W the way it was originally, then I think it's like obvious that this median thing is true. In other words,
really?
I think so. In other words, the reason why we had to prove it was a symmedian was because we let it be like W prime. If it's W, then I think it's just.
Oh, okay. Then it is not important that this. Yeah. Okay.
It's all right. Yeah. But yeah, still, maybe it's better not making it W prime, but leaving it as just W, because then we know that's a median. So yeah, if we know CD is a symmedian here, maybe that's helpful somehow. Yeah, because then if we define W the original way, then it's just we want to show, then we know that angle SWC is SPR. So that equates to showing, that's equivalent, once you do all the angles, that's equivalent to showing arc DB is arc AR. And so that would mean that CD is a symmedian. So maybe we could define like sort of D prime to be so that this is a symmedian and then show those are collinear. And then that would allow us to use harmonic quadrilaterals and stuff like that. So if we do it this way, then we know that ADB, let's see. We know that ADBC is harmonic, right? And so, yeah, we could project through point S and then we'd get another harmonic quadrilateral. So yeah, let's stick with W, defining it the original way. So then we know that AEBC is harmonic. I think that's true. Let me check that. So before we had DBC is harmonic, and then that would mean AEWC is harmonic. No, that doesn't look right. But I got confused. So CP is a median. So a CD is a symmedian. So ADBC is harmonic. And then if we project through S, ABEW is harmonic. Okay, so we draw this tangent, and then AB should pass through that. Yeah, so ABEW, we know that's harmonic if we define W as in the problem. And then we also know that, so AEBW and AHCV are both harmonic. So we have two harmonic quadrilaterals. So we have two harmonic quadrilaterals and we want to show a side of them. Side of one of them is equal to a side of another. Yeah, we just have to project through the right point, I guess. So and yeah, then we could get rid of point D. So ABEW is harmonic and AHCV is harmonic, and we need to show that those two sides of them are equal. So we want to show angle AEW is angle AHV, but AEW is B, wait, but so we want to show angle BEP is angle CHN. I think that's true. So wait, if we can show, let's see, BEP, I didn't click it right. We want to show BEP is CHN. I think this would solve it. Yes. Okay. We want to show, so we want to show EP, BEP equals CHN. But I don't think those are similar.
I found another thing which I don't know if it is useful.
Okay.
The intersection of PT and SN lies on the AC median.
Oh, really?
Yeah. And that looks a bit related because we can use the Pappus's theorem to have collinear points. So intersection of BT and SC, and that point and the G are collinear by Pappus's theorem.
Okay, so these three are collinear. And we think this is the median, and we know AG is the median. So AI and AG would be isogonal. So BEP, we want to show that CHN. Yeah, that's very interesting that this is the symmedian, AI. Maybe AI and F are collinear. Looks like it.
Looks like
no.
EP, HN, and AJ are concurrent.
Oh, really? Okay. EP, HN, and AJ. That's interesting. So we wanted to show BEP is CHN, but BEP is BEC minus CEP. Oh, wait, so really we want to show that angle CEP is equal to, so really we want to show, yeah, CEP equals BHN. I think that's right. AI is not a symmedian. Okay. I'm almost too lazy to check that. Let's see. But I'll go check it. So we want to see, yeah, because it from this diagram it looks at least very close to it. BAI and GAC. It looks like it's true. I think it's true. Yeah, check. But I think I is NS intersect point. I is where NS and PT intersect. Yes, that's what I is. Hold on one moment. PES and NHT.
Yeah, we can prove that AI is the symmedian.
Oh, really?
Yeah, it's not hard. You can use Pascal theorem for 5 points A, B, C, Q, R. We will have that the tangent at A and PN, RQ are concurrent.
Okay, so this tangent at A and RQ and PN concur by Pascal.
Yeah.
Interesting. And so, yeah, if we can show that PE, let me delete this. We just want to show that angle PES is NHT. That looks a little bit easier to work with. PES and NHT. We can show that, then that would solve it. But I'm going to draw those lines first, then I'm going to check the chat. So you're saying this, and this concur.
Yes. So we must have AKAI and APAN are in harmonic.
Okay.
They form a harmonic bundle.
All right.
So we have AKAI, AP, and AN are in harmonic conjugation. And since AK is the tangent of circle APN, so we must have AI is the symmedian.
Okay. AKA, PAI, and those are all in harmonic conjugation. And we prove these are concurrent by Pascal. All right. Are PES and NHT similar? I would be kind of surprised, but it's not impossible. Yeah, okay, they're not similar. But we do have this angle. Whoops. We do have this angle. Oops. Sorry. Equals this angle, and if we can show that, that would solve the problem. So yeah, how do we calculate angle PES? Maybe K, E, and H are collinear too. Yeah, it looks like it. So yeah, I don't know how to prove that part, but it looks like K, E, and H are collinear.
Oh, looks like EHPN is cyclic.
EHPN. And that might prove that those are collinear by power of a point, maybe. Let me check this also. No.
Also, it looks like EN and PH intersect on IG.
Okay. EN and PH also intersect on IG. Okay. So yeah, I wonder if that's like using Pappas. It's not that obvious right now to me why, but it, yeah, it definitely looks true from the diagram. So AI is this median. So if we draw these 2 points in, the problem is basically equivalent to showing an EHOM is cyclic. But we have 2 other circles passing through E and H. So we wonder if that would help. I wonder if OM is parallel to BC. I think by Rhimes' theorem, it would have to be. I think if we could show OM is parallel to BC, that would solve the problem.
We would have to show that EP and H is cyclic first for that.
Oh yeah, you're right.
But that looks like something pretty good.
That looks like it might be easier. Yeah. So once we show this, we'd have to show that this is cyclic and that OM is parallel to BC. I don't think OG and M are collinear, but let me just check. Yeah, that's not true. But yeah, that's a good theorem to know, that RQ, the tangent at A, and Pn concur. I wonder if the point of concurrence here is on the perpendicular bisector of BC. No. Let's see, is HEST cyclic? I think I might have already checked this. Yeah, it's not. So PES is PEH minus HES. And HES is HEC, which is HBC, which is TBC. Yeah, there's a lot happening here. I wonder.
I think we can redefine point V without using the circle T and B.
Okay, so redefine V as.
So maybe we can define V the way that quadrilateral AVCH is a harmonic.
Okay. AVCH.
Yeah.
And then we try to show that that's cyclic. Now let me get rid of this point F. So TNH or TNB, we want to show TNBV is cyclic then.
Actually, you can just define V that way and then prove AW equals AV. Like, because when we have the circle T and B intersects circle ABC at V, then it's not hard to prove that AVCH is harmonic.
AVCH is harmonic. So even if we define it the way like in the problem, then we know AVCH is harmonic, right?
Yeah, true.
So yeah, we really don't need V and W. It's really just the same as showing that PES is NHT. And we want to show this is cyclic. So once we know that these concur, can we like use the radical axis theorem or something? Let's see. So maybe we have like UO times UE. I was going to say equals UB squared, but that's not true because U doesn't lie on the perpendicular bisector. So let's see. Is there any other circle? Oh, sorry. Yeah, I don't see any other circle going through here.
Oh, maybe we don't need to show that EPNH is cyclic. Grimes theorem would suffice from the start, right? Just to show that OM is parallel.
Because PN is parallel to BC, then it follows that EPNH is cyclic?
No, I didn't say that.
Okay.
But we don't need to prove it in order to be enough that OM is parallel.
Okay.
I think. Since if OM was parallel, then that would be Grimes theorem, right?
Yeah. If OM was parallel, then the problem would be solved. Yeah, we wouldn't need to show that first. Yeah. We wouldn't need to show that this is cyclic first. Oh, really? Okay. Yeah, write out the solution. Then I'll type it up. Oh, when you say we can make a new one, do you mean you want to move on to another problem? Oh, yeah. So you want me to go back to the way the problem looked in the beginning? Okay, so if I go back far enough, so this is what it looked like in the beginning, right? And actually we didn't have E or H either, so. So this is what it looked like when we started. What were you thinking? Okay, CS and BT intersect the circle at X and Y. Okay, I don't think we had that before, did we? Oh, actually yeah, so E and H were X and Y instead. Okay. So I'll just rename that X and Y. All right. Draw the symmedian from B and C. Okay, so basically that's the same as those points. So D and so W, YT, and so these are going to be the symmedians. So we can prove that. All right. So BE, CD and BE are the symmedians. All right. CE, wait, hold on. Yeah, actually, now I'm not sure that is true. So let me check if that's true. So 21.76 and yeah, I think it's true. Let me try one more time. So we have CBE is 26.37. Oh, but wait. Why did it look true in one case but not the other? Yeah, no, because this is definitely not. Okay, now I'm confused. D. So DCB is ACP, right? That's a symmedian. Wait, WS and VT. Sorry, because I drew point E wrong. VT. This should be a symmedian. So WS and VT. Okay. So D and E are the two symmedian points. And I can check that. So angle EBA and CBN are equal. Okay. So I have the two D and E are the two intersections of the submedians. So what was your idea from there? XSPB is cyclic. Okay. All right. And I'm guessing that's probably just an angle chase, right? Okay. XP intersects O at U. All right. Angle DSP is half of AW plus BD. Okay, because yeah, DSP, yeah, it's half those two arcs. All right. So DSP is DXP. It's BU plus half B. So BU and AW. So AB is parallel to WU. Okay, that makes sense. All right. And then if WN intersects the circlet V, oh, you called it, can we call it something different from V? Just because V is like from the original problem. Can we call it Z or something else? Okay. Oh, what happened? Oh, YN instead of, okay. So YN instead of WN. And that intersects it at Z. All right. Now W and E look kind of close together, but it's a little better. All right. ZU is parallel to BC. Okay. So let's see how you might have done that. Yeah, I want W and E to not be so close and Z and U to not be so close. It's tricky. Okay, so yeah, if we can prove that, that would solve the problem. Because that would mean TYN is PXS, and that's what we showed before, that that would solve the problem. Okay. Okay, so that's equivalent to saying ZB over ZC is UB over UC. Okay. Okay. So sine BXP over sine CXP. Okay. All right. That makes sense to me. Like sine Ceva for XBD and point P. Do you mean XBC? Okay. Okay, I think I see. So all right. So then you would need to show that sine XCA over sine BCA. Oh, Okay, so after you do the law of sines, I think it would be equivalent to showing that sine let me think about this. The sine of this over the sine of B. Okay, so you have, okay. Sine, yeah, BCP over PCS, and you'd have to show it's okay. That makes sense to me. And BCP is a median. PCS. Oh, but because, okay, so this is a median. Okay, so yeah, how would you get angle PCS in that equation? Okay. And I think it's sine ACB, but I see what you're saying for the second one. BCP. Oh, so you just rewrote it. So XCA over PCS. Yeah, so you just switched it around. All right. One moment, I'll be right back. All right. Let's see. So sine XCA over sine PCS. So XCA over PCS, that's AP over PS times CP. Okay, so you turn that into ratios. So BCP over ABC. All right. So we want to show AS over SP is AS over SP and AT over TN. Okay. So you want to show the ratio is like AB squared over AC squared. All right, I'm gonna write some of this up. So let's CD and BE. Okay, so all right. So the tangent at A, ST and PN concur. All right. All right. Wow, this is a really interesting solution. And then that solves it. Okay. So I'm gonna try to write this up. Okay, so let the submedians from B and C meet the circle at D and E. Okay. And then let make some more room here. And then let CS and BT meet the circle at X and Y. And then by an angle chase, PSXD and NTYE are cyclic. Yeah, there's just so much going on here. It's crazy. Okay. And then we have, so I'm just going to copy paste a bunch of things that he wrote. So, okay, so we're going to try to prove that ZU is parallel to BC. So we have I'll say define Z and U as shown. And then ZU is parallel to BC if and only if ZB over ZC is UC over UB. And okay, we have this. And then use it by Trig Ceva. So we apply sine Ceva for XBC. And then that's true. Yeah, I'm literally just going to copy a bunch of stuff because I know it's like a really long solution. Then that, and then this. And then, okay, so by Pascal's theorem, those have a common point H. And by Menelaus, this is true. And so this, so once we have that, that implies ZU is parallel to BC. So then we have ZB over ZC equals UC over UB, and that means ZU is parallel to BC. Once we know that, then that means that angle PXS is equal to angle NYT. And that means that angle BXP equals angle CYN. CYN. And so BXP is a symmedian. So AXC is the, sorry, now I'm getting confused. So how did that end up solving it? So what did we do once we know this? I forget how we finished. So because we know that AV, what did we know is harmonic? AW, so yeah, what did we know was harmonic? I already forgot. AW, this is driving me crazy. Okay, so since they're symmedians, D and E, we know AECB is harmonic. So that means that ACV AVBY is harmonic. Okay, so since ABCE and ACBF are harmonic, that means that AVCY and AVCY and AWBX are harmonic. And then from there, I think it's angle chasing, because showing that because we want to show that angle AYV is equal to angle AXW. But AYV is ACV. I forget how to finish this. Okay. I know we figured this out before. I just can't remember it. This is so complicated. Let's move these up. AW equals BU. Oh, okay. So AW equals BU. How do we know that? Is DSP is DXP. Okay. So DSP So I'll just say equals CZ equals AB. So did we even need that these? Okay, so we don't need these harmonics really. We could just finish it off like that. Okay. So, all right, I'm going to move on to the next one, but I think, yeah, this works, or it should work. All right, so here is the next problem.